Hello everyone, this is a video lecture for Algebra 1314. We're doing 9.3. So this chapter 9.3 is coming first. We will be doing 9.1 and 9.2 next time. So why are we doing 9.3 this time? Whatever. So I'm just going through the workbook. So we're doing matrices. That's the big thing here, matrices. And I'm going to tell you that Desmos matrix will have everything you need matrix-wise. See, it's like they already start setting it up for you. So we're going to do Desmos a lot here, and that is the primary thing. We should be using Desmos for this last stretch of the class. Okay, I don't do any of this by hand. Just between you and me and everyone else listening, I don't do anything here by hand. I just don't, because Desmos does it all for you on purpose. Okay, that's a good thing. So let's go through it. Matrices are just kind of like big blocks of numbers, and we're going to be using them for specific things in 9.1 and 9.2. But here we're just kind of adding up some numbers together. The very first question is asking for A32. Whoa, 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 whoa. A3 comma 2. Oh. And so how it goes is that this is a row, or these are your rows, this is your column. And so I'm saying row 3, column 2, match it up, and there's your answer, okay? Pretty simple. And so if they say 2 comma 3, then they're saying 2, 3, there it is. So it always comes in rows and columns. So the size of this thing would be 3 rows by 4 columns. Again, this is always rows and then columns. That's how you get the size. So I could put that in here. See, 3 by 4, 3 rows, 4 columns. So now I can start putting those in there if I wanted to. I don't want to, but you get the point. Okay, so that's a matrix. So they want you to start adding them up or equaling them and all that stuff. I think the next thing is going to be adding them and stuff. So this one's pretty simple because this equals that. They're the same thing. So this top corner is the same as this top corner. 12. I'm dead serious. That's all it was. This bottom corner is the same as this bottom corner. 20. This 4y is equal to 4. Now hold up. We actually got to do math for once. Divide by the 4. We got 1. That was easy. And then 15 equals 15. Good enough. It's just that easy, truly, truly. So we're going to do this adding and subtracting of matrices right here. I just want to show you to do it by hand like one time, and then for all the rest, we'll be using Desmos. So they're going to say find a plus b. So I'm basically taking a big plus sign between them, and then I'm going to find out what numbers they're going to be. So I match up the top corners, and I add them. So this plus that is equal to, so that's a negative 9, and that's a positive 8, so we get a negative 1. I got negative 3, negative 8 would make a negative 11. I got a negative 8. I got negative 5, 2, negative 15. There's your answer. We're done. There it is. So what I want to do now is use Desmos matrix for all this stuff because it's like way better. So I have A, and that's a 3 by 2. So 3 rows, 2 columns. And then a B, so I do new matrix, 3 by 2 again. And then they say find A plus B, so I type A plus B. Wow, look, I got the exact same thing, and it was immediate. So you can see that it's no big deal here to do this. Awesome. So how do I find A minus B? I do minus sign. I mean, that's all we're doing here, guys. I just type in whatever they have there into Desmos. We are not cheating. This is not cheating at all. In fact, if you're wanting to go like by the standard of the other algebra class, they're now allowed to use Desmos for this kind of thing. So we're on par with the other class as well. Okay. And then finally, the last one, 3a minus 8b. I mean, again, to multiply the 7, it would just be distributed and all that stuff. It's not hard to do these things. Like, look, that's why I got 9 times 7 is 63. I'm sorry, yeah, 9 times 7. 6 times 7 is 42. So it's all right there. It's very simple. It's very, I guess, normal. What you think that you would do is what you do. There it is. That's it. We're done. Yay, we did it. That's a lot of white space for nothing. So, matrix multiplication. Yet again, this is just going to be Desmos. A lot of times I like to show how to do this by hand once. But, I mean, really, it doesn't matter. It doesn't matter. You're going to need to just do this in Desmos. Doing it by hand is very long, especially with all these crazy numbers. And it just, in the end, that's it. It says find A times B, put A times B, and there you go. Now notice that the size is a little weird, okay? That's fine, that's fine. Let me write this down and I'll explain. Okay, cool. And then they say find B times A, and that's weird because the size is even weirder now. Okay, we're done. That was it. We did the whole math problem. Like, there's nothing else to do in my math lab. You're done. But let's talk about it for a second. When you multiply, you have to make sure that the sizes will kind of like match up in a way. So this is a 3 by 2, and this is a 2 by 3. Again, rows, columns. In order to multiply them, you have to have the inside numbers to be the same. And so that's true, so we're good. The result will be the outside numbers. So this is a 3 by 3 result whenever I multiply them. So that would be A times B. We got a 3 by 3, as you can see. We're good to go. If I flipped them and I had the 2 by 3 and then the 3 by 2, you can see that my inside numbers are again the same, so that's good, but the result is a 2 by 2 result, and that's how we got this guy right here. One thing to note, and this is right here, it says it is commutative. It's not, so like that would have been a false, of course. It's not commutative. Commutative means like 2 times 3 is equal to 3 times 2. That would be commutative. That's not the same here in matrix land. A times B is not equal to B times A. So I just want to make a little emphasis of that. A times B is not equal to B times A. They're a little different. I know that's weird, but that's how it happens. And you could see, I've proven it right here, that they are different. Those are totally different results. Okay, so let's do it again with these guys. Now, notice that they're like ones, so it's like it's 1 row, 4 columns, and I get mixed up when I do this sort of thing too. So just make them look the same, right? 1 column, 4 rows. Cool. A times B, B times A. And you can see the sizes are very important here because when you multiply them, you're either going to get a 1 by 1 or you're going to get a 4 by 4. Same style. If you're looking at the results, the answer of the 4 by 4, do you see a pattern going on? You see the pattern? It's like all my 2s, 3s, 4s, and then my 5s. That's not really a coincidence, given that we had 1, 2, 3, 4, 2, 3, 4, 5. So there it is. I don't know. There it is. I do know, and that's what you do. Okay, we're going to do the same thing for this one. But first we need to solve this equation, solve for x essentially. So I got 2x plus a is equal to b, and then they say solve. So I'm going to minus the a on both sides. And I'm going to divide by the 2. I'm a little picky about this because Desmos used to not allow division in the matrix calculator. So I do a 1/2 in the front. This is what you're going to type in to Desmos this time. So let's put in our A. And I know it's a little bit long to type these matrices. It's like, it's a little boring to copy them down. And if you do copy it wrong, then the whole thing's wrong, and you get the idea. But it is much faster than doing it by hand. So I have a weird thing here, but they want fractions, of course, and that just, there's a fraction button, so click it, and you're done. It's just that easy. Okay, we're done. Last one, I think. Is this? Nope, there's still some more applications. Okay, I'm going to add the x to both sides. I'm going to add the x, and now I'm going to minus the 4a. And so then I got x is equal to b minus 4a. There's a few ways to solve it, but as long as you do that. Put them back in, get the answer. Man, I'm looking at it like, man, do I really have to do this? But I guess. If you get something wrong, I would say first check to see if you're typing it in correctly into Desmos. Because like if you did like a 6 here, obviously the whole thing's wrong, but you're not really wrong. You get the idea. Okay. 35, 2, 4, 7, negative 29. There it is. Okay. So application stuff. I think there's not too many. There's this one, then there's the L problem, and I think we're done. It's not too many things. So we're changing the color, the contrast of this from light gray, dark gray into whites and blacks. And so what we're going to do, ultimately the goal, is that we have a 1, a 2, a 1, a 2, 2, 2, 1, 2, 1. But we're wanting to convert that into a 0, 3, 0, 3, 3, 3, 0, 3, 0. So like the darker, the dark gets darker, the light gets lighter, that kind of thing. That's what we're wanting to do. So it says represent there's your answer. There's your answer. It's right there. It says, what's the result going to be? And it's right there. We already did it. So what would you add? This is the interesting thing. So what would I change? How would I represent that in a matrix, the change? So I'm going from 1 to 0. So like I'm subtracting 1 right there. But here I'm going from 2 to 3. I'm adding 1. And then I'm minusing 1. I'm adding 1. I'm adding 1. I'm adding 1. Minusing 1, adding 1, minusing 1. Okay, so that's your answers. I don't even remember if this is still on the homework or not. But the idea, though, is that you can copy this down, and then you add it to this, and then you get this result. So it's like this plus that equals this guy here. Okay. All right. I don't know. It's really not as hard as it looks. It doesn't even look hard. Okay, so the L problem. There are definitely L problems. I think there's even 3 of them on the homework. So in the end, let me show you how this works. We need X's and Y's as 2 separate rows. And so when I start creating this matrix, I'm looking for each point here is an XY point. So let's start here at 0, 0. And so I would put 0, 0. Doesn't look very good. There you go. The next point right here at 4, 0, so I would put a 4 and then a 0. This one's a 4, 1. So 4, 1. 1, 1. 1, 6. 0, 6. Try to correct that a little. Oh, man. 0s and 6s. There you go. So that's my B matrix. What we're wanting to do now is move it around. So in this case, they say 3 units to the right and 2 units up. You can see it's up right there. 2 units up. So we're going to the right. We're going to go up. Well, when I go into the right, I'm basically adding more x's. So my x's, I'm going to say plus 3. And then going up, I'm going to say my y's plus 2. So all my x's up here, I'm going to add 3 to them. And all my y's in the bottom, I'm going to add 2 to them. And so on the top, I'm going to add 3's. Okay, so here we go. 3, 7, 7, 4, 4, 3. And then the bottom, I'm adding 2's. So 2, 2, 3, 3, 8, 8. There it is. And then it says which graph went to the right and then up, obviously. So not too bad. On the homework, there's another kind of question like this where they have an A matrix. And the A matrix looks something kind of like 0, 1, negative 1, 0, something like kind of like that. And then it says find A times B. Well, you can do that over here, right? You do A, you got B, you say A times B, Desmos. Okay, so that's another way to do it. Cool. I think that's all we got. It was actually pretty fast and easy. We're going to do the rest of the matrix stuff next time. So thank you very much. Have a great day.